Hey. Today we are talking about quadratic equations. All right, quadratic equations is the standard form is ax squared plus bx plus c equals 0. Okay, so this part right here should look familiar to you. And you're like, what do you mean? Well, it should look familiar to you because that is where we were factoring trinomials. So this is standard form. So what are the steps in solving a quadratic equation? Okay, so steps for solving quadratic equations. Okay, so here we go. Number one, get equation into standard form. 2, factor the non-zero side. And this would be the non-zero side because it's not equal to 0. Okay. Step 3, set each factor equal to 0. And 4, solve. Okay? All right, so before we even get into an example problem, let's review. Okay? Let's review on factoring. Okay? So this is a very popular subject. In fact, I'm going to make that. There we go. So let's review factoring. So factoring. What is the very first step in factoring? Yes, GCF. Okay? So in fact, I'm going to do this. I'm going to bring this all the way over here. I'm not sure where this is going to go, but we will find out together. Okay, so after GCF, where do we go? What is the second step? So we're going to look at, let's do it this way. Well, all right, so let me do this. So that's what that result is going to look like, right? So it's going to look like that. So we're going to look at what's left. And ask how many terms. Okay? So, A, if it is 4 terms, what should we do? If it is 4 terms, actually, you know what? Let's do this. If it's 4 terms, what do we do? Okay, we do factor by grouping. Now here's my question. What are the steps in factor by grouping? right? We want to separate the first two terms from the last two terms. And then factor each group separately. And then factor as a whole. Okay, so that is 4 terms. Choice B. Three terms. What do we do? The AC method. Or the trial and error. The AC method, what was step 1? Step 1 was finding A times C and B, right? And we're looking for two numbers multiplied together to give you the product of A times C, and the same two numbers added together, or the sum of those two numbers, will give you B, right? And then step 2 was to use results in step 1 to split the middle term, right? And then step 3, factor by grouping. Don't like my writing there. Notice I put in orange. Look at that. All right. What's the last choice? Two terms, right? What do we do with that? All we do is ask the question, right? Ask the question, right? What is the question? Is it the difference of two perfect squares? Okay, so the example would be this. If I had a squared minus b squared, it would factor to be a plus b times a minus b. Okay, so there you go. So that's like the summary of factoring. Okay, so now let's get into some examples of quadratic equations. Okay, so quadratic equations. So let's see here. Let's say I have 12x squared plus 5x minus 72 is equal to 0. So my first question is, do I have a GCF for the x's? And the answer is no, because there's no x's here. Okay, so therefore no GCF there. Okay, how about, does anything go into 12, 5, and 72. So since 5 is a prime number, that's a great question to ask. Does 5 go into 12? No. Does 5 go into 72? No. And the reason why the 5 is good because it's a prime. So it only has a factor of 1 and itself, and that's it. So since it doesn't, then we're kind of stuck. There's no GCF. Then we go into what's left, right? How many terms do we have? We have 3 terms. So then we got to look at the 3 terms and use the AC method. So, okay. So A times C is equal to 12 times negative 72. Uh-oh, big number. And B is equal to 5. Okay. So let's see what 12 times negative 72 is. 12 times negative 72 is negative 864, and my B is 5. Whoa, this one is huge. Okay, so we got a really big number. So we got to figure out what those 2 numbers are, right? So we got to say, well, I got to find these 2 numbers here. So what I will do is take the negative 864. I might as well use this now. Okay, so I start going. So these 2 numbers added together has to give you 5, positive 5, but I want the result to be negative, the product to be negative. So that means the larger number is going to have to be positive and the smaller number is going to be negative. All right, so it's going to be a negative 1, 864, right? So 864 divided by 2, negative 2, 432. Whew. Does 3 go into it? I'm going to say no. It does. Negative 3. Oh, because it's 18, so yes, it does. And 288. So if you notice that the difference here is, still a lot, right? 4 definitely goes into it. All right, so here's where I'm starting to think. All right, I need the left side of the number getting smaller, or in the negative, so bigger really, and the numbers on the right to get smaller so that we can get closer to a difference of 5, okay? So let's try, let's try negative 8. So 864 divided by 8. So negative 8 is 108. Well, that's still 100 versus 5. So let's try 16. I should get 54. Getting better, right? Let's try 32. Uh-oh. I seem to have gotten it flip-flopped. So here, notice how the smaller numbers on the left-hand side and the larger numbers on the right-hand side. Well, when I wrote this one, the smaller number is now on the right-hand side. So I should have wrote this. So 27 times 32 gives you 864. So I could just flip this around and say it is negative 27 and positive 32. Okay, so you're probably wondering why I started going, why did I pick 32 after 16? Why did I pick 16 after the 8? And here's the reason. So here's where you need to pay attention. Ready? So what I noticed is that this was even. Okay, so if I was to divide this by 2, then I would have to take this and multiply by 2. Okay? So since I did that, that's why I picked negative 16, because that would be double of negative 8. So therefore, On the other side, on the larger side, I would divide by 2, so it's half. And then I did it again to get that 32, and then did it again to get to 27, okay? So that's how I went about doing it. And I always like to get at least like 1, 2, 3, 4 into it, or maybe 5, maybe 6, depending on what's going on. Now, I knew 5 wouldn't go into it because it doesn't end with 5, right? 6 would go into it because if you look at -3, if I double -3 be -6, that means I would have to take half of 288. So -6 would go into it as well, right? So I could have done it that way, okay? So I could have went from the 3. So so that's the way I would have, just kept on going. Now, did I know it's going to work out right this then and there? No, I had no idea. I just had to keep on working. So I'm looking at these two numbers here, okay? So let's check. Does -27 times 32 give you -864? Yes. Does -27 plus 32 equal to 5? Yes. So, okay, so those are my two numbers, -27 and 32. Oops. So I come back over here. So the only difference of this right now with the quadratic equations and what we've been learning with factoring is that we added a equal 0. Whoa, okay? And we'll explain why the equal 0 is there. All right, so I have 12x squared minus 27x plus 32x minus 72 equals a 0, okay? Then I got 4 terms. I need to factor by grouping, all right? So I need to look at what's the GCF on the left side. So what goes into 12 and 27? So let's try 3x. What do I have left? Oh, I'm sorry. Yeah, that's the 12. So I have a 4x minus 9. Okay, now let's look at the right side. What goes into 32 and 72? 8 does. How many times? 4x minus 9. Oops. Okay, let's see which one I have here. Okay, I got the eraser, so I can do this. Perfect. What's in common? You got the 4x minus 9 and the 3x plus 8. Okay, so now you got to put the equal 0 back, okay? So remember when I first started this whole course, I said that everything in parentheses is essentially a number. So if you look at this is a number, and this is a number. We just don't know what x is, so we don't know what the number actually is, okay? But if I'm taking the product of two numbers and it's going to equal to 0, that means either one or the other has to equal to 0, right? So in order for me to find x, I know that one or the other has to equal to 0. So what I'm going to do is I'm going to take the 4x minus 9 and set it equal to 0. And I'm going to take the 3x plus 8 and set that equal to 0. And I'm going to solve for x. So what do I have to do here? I have to add the 9. And then divide by 4. Over here, I got to subtract the 8. Divide by 3. So there would be my two answers. So typically I would write it as in a set notation because I'm giving a set of answers here. -8, 3, comma, 9 over 4 and close squiggly. So that would be my answer. Okay? So, again, GCF, well, standard form, which it already is, awesome. So x squared, then x, then number by itself, right? GCF, no GCF, then the AC method, split the middle term, and then factor by grouping, get my factors, which is the 4x minus 9 and the 3x plus 8, set each of them equal to 0 and solve. Okay? Let's try another one. So they might be a little tricky and give you something like this. They're trying to be tricky, but it's not very tricky. Now with this, because it is already the product of two numbers equaling to 0, then there's not much work that needs to be done. It's just going to take each factor and then set it equal to 0. And solve. Add the 7, divide by 2. Okay. Voila, just like that. So now you're going to be like, well, that was pretty easy. So why, when is it going to be looking something harder than that? All right, and why is it tricky? And here's the reason why it's tricky. So let's say I do another example, but I have x minus 1 times x plus 4 is equal to 14. Let's say that, okay? So let me rewrite this part really quick. Okay, so if I have this, I can't set each factor equal to 14. That wouldn't be true, because then you're saying that this first number is equal to 14 and the second number equals to 14. So you're saying that this is equal to 14 and this is equal to 14, and we multiply 14 times 14, it does not equal to 14. Okay, so that's why you can't do that. It's probably easier for me to just erase that. So what you would have to do, where here you could, because 0 times 0 would equal to 0, so that would make sense. But 14 times 14 wouldn't equal to 14. So are you going to just guess which one's 2, which one's 7? You can't do that either, because now rationals are in play as well, so that means decimals. There's a lot more into it. So what we would actually have to do is break the two numbers apart by double distributing, and then bring the 14 over so that we can set it back equal to 0 again, and then go through all the steps again. So first thing I want to do is double distribute this, or FOIL. Okay, so let me do this really quick and grab nothing else. So I got to double distribute this. So this is going to be x squared plus 4x minus 4 is equal to 14. Combine like terms. Bring the 14 over by subtracting 14. Now, is there a GCF? Answer is no. So I go to the side, say, okay, A times C is equal to negative 18. B is equal to 3. So I need to find my two numbers. But since A is equal to 1, right? So let me see. Let's find these two numbers first. Let's try negative 3 and positive 6. So check that. Oh, sorry. This is supposed to be a plus. So check that. Negative 3 times 6, negative 18. Negative 3 plus 6, positive 3. Awesome. I got it. All right. So here's the nice part. So some of you guys already know what I'm talking about when I say, look, A is equal to 1. So I'm going to just keep on going. But you guys already know, then you guys can kind of fast forward through this video to catch up or to get to where you want to meet me back again. So GCF is x, leave me at x minus 3. GCF over here, what goes into 6 and 18? 6 does. Awesome. So x minus 3. So what's in common? X minus 3. What do I have left? X plus 6 equal to 0. So x minus 3 equals 0. X plus 6 equals 0. So x equals 3 and x equals negative 6. So I have, oops, thinking too fast. Okay, so negative 6 comma 3. And there is my answer. There we go. Okay. So understand that this is different from this. This is already set equal to 0. So I can say each one equal to 0 because 0 times 0 would equal 0. Where here, I can't say each one equal to 14 because 14 times 14 doesn't equal to 14. Okay, so that's the reason why I had to kind of break this apart, bring the 14 over so I can set it equal to 0. Then I can have that. All right. Let me see. What else would you have? So in other words, if it's not set equal to 0, then that means you got to undo everything to redo everything. Okay. Now, I'm going to say to you, I'm going to end this right here. But here's where my warning is going to be for you, okay? The warning is going to be this. Number one, just because the standard form is this, okay? Don't assume that every single one of these problems is going to be a trinomial. It's always the AC method. The reason why I review factoring is because it's not just always 3 terms. It could be 4 terms. It could be 2 terms, okay? So don't sit there and think that it could, it's not one of these, but don't forget that GCF is always going to be first, okay? Because some of the binomial problems or the 2-term problems, you're going to think, oh, it's not the difference of 2 squares. But then when you pull a GCF out, it now becomes a difference of 2 squares, okay? So please be careful as you're working. And sometimes you don't even need it to be a difference of 2 squares. Then you already have 2 factors that you can actually solve for. All right. So I'm going to leave you here and let you kind of do a little bit problem solving with some of those problems. If you have any questions, obviously, please get a hold of me.